Hello, this is FlippedHarber for Algebra 2. In this video we're going to talk about transforming polynomial functions. The objectives for this lesson include transforming polynomial functions. The outline for this video will talk about the different transformations of polynomials. We've talked about transforming other functions before, so a lot of this should feel very familiar. Then we'll talk about translating a polynomial, reflecting, stretching, and compressing a polynomial function. So these transformations of polynomials should look very familiar. We've talked about vertical and horizontal translations before, about adding a number to the end of the function or subtracting a number inside with the x. Vertical stretches and compressions, we multiply on the outside. Horizontal stretches and compressions, we divide by what we want to stretch or compress by inside. Reflecting across the x-axis, we put a negative in front of the whole function. If we reflect over the y-axis, we just put a negative in front of the x. So here you see some f of x notation, meaning the very generic, non-specific form, and we see some examples. Now, the rule that I've always tried to get across to you is that inside changes always look opposite what we would expect. So that's always true. I tried to state that rule so that you can always follow it no matter what type of function we're talking about. And again, it works with polynomial functions. So let's take a look at translating a polynomial function. We want to take the polynomial f of x equals x cubed minus 2x squared plus 3x minus 4. We want to move it up 3 units. Now that's not difficult. Moving it up 3 units, we're just going to add 3 to the end. Moving that function left 2 units, that means that I need to add 2 to every single x. Don't just do it to the first x, don't just do it to the last x. Add 2 to every single x in the polynomial. So here we see what the transformed polynomial should look like. I've added 2 to every x value, and that's going to move it left 2 units. I've also added 3 at the end in order to move it up 3 units. Now this is a great beginning, but you still need to actually simplify that out. You would want to use binomial expansion on this x plus 2 cubed. You would want to use the pattern, or again use binomial expansion here. You also want to distribute the negative 2 in. You want to distribute the 3 in. And you always want to end by combining like terms. Now we're still going to have an x cubed function. There's still going to be an x cubed term, there's going to be an x squared term, there's going to be an x term, and there's going to be a constant at the end. So the form of the polynomial doesn't change. It's just the numbers in front of each of those coefficients is going to be different. I'll leave the simplifying up to you. So let's take a look at reflecting a polynomial across the x-axis. Now remember, if we want to reflect it over the x-axis, we put a negative in front of the whole function. So notice that that negative is outside some parentheses, and that negative needs to go to all 3 terms of this polynomial. So it would become negative x to the 4th plus 5x minus 6. Alright, what about stretching a polynomial? Well, if we want to stretch it horizontally by a factor of 3, now that's going to be an inside change, and you would think that to stretch it, to make something bigger, you would multiply by the 3. But remember, inside changes are opposite what we would expect, so we actually divide by that 3. Now I do this to each and every x. Again, I'll leave the simplification to you, but really all you need to do is put the 4th power on the 3 and put the 4th power back on the x. Square the 3 and square the x again, and try to make it a little bit neater. Compressing a function vertically by a factor of 2. This is going to be an outside change. If we want to make something smaller, compressing means making it smaller. I'm going to go ahead and, that should be dividing by 2 on the outside, not multiplying by 2. That should be a 1 over 2. Oh well, I'll fix it next time I do this video. Alright, so that's it for this section. Not too difficult. You should be very, very familiar with these transformations. Okay, I'll see you in class, and I'll see you online.